Welcome everyone to today's session. I think the topic itself is quite exciting. So I think we'll have a lot of good time making this game. As you can see, the topic for the day is create your own Flappy Bird game in just about 60 minutes. So if you remember back in 2013-14, there was this very annoying, weird little game that became very popular. And before we get started with the development side, I just want to quickly give you a brief about the game itself. So Flappy Bird was a simple mobile game developed by this Vietnamese developer Dong Nguyen, and it was essentially just a regular game that was not that popular as such. It took about a year for the game to actually become successful, and the way that it became successful was also very weird. One popular YouTuber just uploaded a video saying that do not play this game, and suddenly overnight everyone started playing the game. So the popular YouTuber that I'm referring to is our beloved PewDiePie, and after he uploaded that video, this game became so popular that at its peak it was earning $50,000 a day. So $50,000, if we were to just do some napkin calculations, that's around about 40 lakh rupees a day this game was earning. And that's a very huge amount for an indie game developer, right? And the reason why we are taking this session, and I'm very grateful to Hero Wired to host this session, is because this will give you an idea of how you can create your own game in a very short amount of time. So the session right now is create your own Flappy Bird game in just about 60 minutes. But whatever code I am showing you right now, I made that in exactly 33 minutes. I actually timed myself back in the day when I was writing this code, and you can also do this. It's not that complicated. Obviously, if you were to kind of create your own game and you want to polish it, then of course there needs to be a lot of other aspects that you need to put your mind into. But on the face of it, if you were to just create a base game, you can create anything in a matter of a few minutes. So with that in mind, without any further ado, I would like to share my screen. What we have done here is we have created this pre-made script for you all. If you want to basically access this, all you need to do is go ahead onto your GitHub. We have also passed on a link to this source code to you all. I'll just quickly type this into the chat as well for anyone who hasn't been able to get access to the code. I have hosted this onto GitHub. So this is a public repository. You can directly clone it, or you can download this source code as a zip. The current version of this game is in 2018 version of Unity. You can also upgrade it to a newer version of Unity. There won't be any issues that you'll face as such, because the code as of now is extremely basic. So as you can see, like currently it has just 3 commits. It's a very old source code, but what I've made sure is that I've written it in such a way that it is expandable and you can build on top of this. And it's a very basic source code. You can literally like change any kind of assets that you want. You can add in new functionality and whatever you want to do, essentially, right? So this is a source code. If you want to download it, either you can download it via GitHub desktop, or you can download it as a zip folder. If you download it as a zip, you will get this Flappy Bird master.zip in your download destination, and you can just kind of extract it into a folder, and you will get something like this as your project structure. It's a regular Unity game engine project. So whatever, it's basically the same process of opening and getting any other Unity project. And once you do so, you will get something like this. So as you can see right now, I'm using Unity 2018.4.24 F1. As I mentioned, the version number is not that much of an issue, but I would still recommend use either 2018.4.24 F1 or higher. Okay. And I'll just quickly walk you all through the project structure. It's very basic, very simple, very easy to understand as well. There are just four folders within the project folder. One is your prefab, second is scenes, third is scripts, and fourth is sprites. Now, for those of you who don't know what a prefab is a prefabricated object which you create so that you can reuse, over and over again. So if I go to my scene mode right now, you'll see that this is my scene, okay? And this is the pipe that we have. If I click the play button, what will happen is, now since this is something that I've already created, the output is out there, right? Output is visible. Now you can see we have this one pair of pipes that came, then there's a second pipe, third pipe, so on and so forth. So what is happening over here is that these pipes are getting generated automatically for us. And right now, if we snap out of the scene mode, we can see that there is only one pipe. So naturally, we have created some sort of a script that allows for us to generate this pipe at runtime. And not just that, if you were to see this entire, one second, I'll just move this. Yeah, if you were to see this entire structure over here, I go to the play mode and I go to my scene view. Ah, obviously there's a game over that happened over here, but I'll just do that again. So if we see over here, now pipes are starting to spawn over here, right? Now, naturally, there is some sort of code happening in the background for this to actually happen, right? Of course, the basic understanding over here is that you have some bit of an understanding about how Unity game engine works. If you don't have, I'm sure Hero Wired has a lot of interesting programs that can also teach you how to create such experiences from scratch. The idea with this session is that you can to expose you to the world of game development and to enable you to and to show you that with very basic and minimal knowledge you can create something very interesting that can be played by millions and millions of people. So as a continuation to my previous justification of why you need to kind of focus on creating small experiences is because even making a small game as simple as a Flappy Bird can have a huge impact. And secondly, when you're creating your first game, it is always a good idea to start small. I mean, I'm sure all of you guys want to create the next Grand Theft Auto or a Need for Speed or any big MMORPG game, but chances are that you will be able to make it eventually, but not at the very beginning, because game development as an entire process is extremely complicated, and you need to have a look at a lot of other things. Like for example, even in this very simple game, there can be n number of issues that can take place. Maybe your bird is not spawning properly, maybe your inputs are not correct, maybe your scoring system is broken, maybe the physics is not right. So there can be a lot of things that can actually go wrong. Now, we saw what a prefab folder is. Prefab is essentially any object that you want to reuse over and over again. And over here we have pipes as our prefab. Okay, that's the only prefab that we have. Of course, if you want to have any other objects, then you need to create prefabs and functionality of those. If you kind of bifurcate on pipes, what is happening exactly? So if we look at the right side in your inspector panel, we have a lot of values that are over here. So you can see there is your transform, your pipes, which is a custom script that we've written. This is a script that is responsible for moving the pipe from right to left. And as you can see, there are two variables over here. One is our move speed and second is kill position X. To just explain simply what these two variables do, move speed is the speed at which the pipe is moving, and kill position X is basically, if you understand the coordinate system, things generate from 0, 0, 0. So here what we are telling to the script is that if you reach a certain point inside and if you go beyond that point, just destroy that object. Okay, we will come to the script explanation part very shortly, but I just want to first explain the project folder structure to you. We come back to our assets folder. Now, in scenes, this is quite self-explanatory. This is the sample scene. When you're working or creating a game, there are n number of scenes that you can create. So they can your main menu can be one scene, your gameplay can be one screen, your credit screen can be one scene, or if you want to add some sort of a settings screen, that can be one scene. Typically, the structure of a scene is that if you want a level-based games, so developers kind of create different levels inside different scenes. Right now, since this is an endless game and it has only one functionality, the game has only one single scene, right? Now we come back to our assets. Now this is where all the interesting stuff is. In scripts folder, we have 1, 2, 3, 4, 5 scripts. That's it. In 5 scripts, you are able to create this game. And this is also quite self-explanatory. I'll get into the details of that too. But before we do that, I just want to tell you that whatever we've created right now over here is just very basic functional gameplay. there is a lot of things that goes into picture beyond this as well. So you have to do a lot of other code stuff. If you want to handle the exit screen, if you want to kind of add show ads within the game, that is another functionality. If you want to add in-app purchases, that is also a separate process. But at its core, this can be counted as something of a game, right? And but right now, I am using Unity onto my PC, but Flappy Bird is a mobile game. However, all the scripts that I've written are 100% mobile compatible. So you can also use this script, download it on your end, create an Android build, and test it onto your phone as well. So how would you do that? You can just go to File, Build Settings. And guys, I'm using a Macintosh system. I'm on Mac, but the same similar settings and options you will find inside your Windows as well. So build settings is also a part of the Windows Unity system on your end too. So you go to build settings. Right now you can see there's a platform. We are on platform PC, Mac, and Linux. All you need to do is go to click on Android and do switch platform. Now, once you do switch platform, it will kind of compile things on the background. I don't want to do that here right now in the interest of time, but you just simply switch platform and then create a build of it, transfer that build to your phone, and you can check the functionality of this game. So you can do that, and how we are able to make that possible, that is also something that I'll explain to you once I explain the project folder structure. We'll go back to our assets folder, and the last folder that we have over here is the something known as sprites. Now, what are sprites? Sprites are basically all the images that will go into your game. If you can see something, I'll go and switch to my scene view. You can see that there are two pipes over here, but we can only see one pipe over here. That is because we have simply just duplicated the pipe and made sure that the pipe is upside down, so that we are able to get two sort of pipes within our game, right? So this is just a duplicate copy. Whatever you can see over here, this is the bottom pipe is basically just a flipped version of the upper pipe. And there's another sprite over here, which is our bird, which is our main player that we can see over here. Okay, so two sprites, five scripts, four project folders, one scene, and one prefab, right? This is all you need to make a basic working Flappy Bird prototype or a game. Even a simple game can be created something like this, right? Now over here, we also now we go into the workings of the game. What is actually happening? So you can see we have a bird over here, and we have these pipes. The core functionality is that the bird moves up. We get a small force inside the bird, but once we tap on the screen. So if I just go to my game view and I hit the play button, and we start playing the game, and I'm clicking on the screen, and if I collide with a pipe, then my game is over. And then we have a menu screen that says retry, and we go inside this entire code loop once again, right? And as you can see on the left hand side, once the pipe crosses a certain section, those pipe get vanished from the screen, right? Or they disappear from the screen. So that is the core gameplay. Now, what is responsible for this gameplay to happen are two major things. One is our game manager, and second is our UI manager. What is our game manager? Game manager keeps track of the entire gameplay. And we have the script of game manager over here. I clicked on the game manager, and we can see there are multiple objects over here. There is inside our hierarchy mode. Okay, so we have a main camera, we have bird, we have game manager, UI manager, pipes, spawn manager, canvas, event system, kill trigger, and kill trigger. The two main objects over here are game manager and UI manager, and these are our custom scripts. And the other important thing from Unity is canvas. And if we just expand the canvas a little, we have our score. This score corresponds to this text that we have, which basically shows the user how many pipes they have crossed. So if I just remove this from my inspector panel, if I check or uncheck, I'll be able to see that I'm able to see the score. But if I uncheck this, my score vanishes. That's one. Then second, we have game panel, and within game panel we have something known as a jump button. Now the jump button by nature over here, or by design, we have kept it completely transparent. But if I were to just show you what the jump button is, it's basically a button that is covering your entire screen. Okay. I'll just quickly show you. So if you can see over here on the right hand side, inside my color, in my image, in my color, I now can select my color, but here the transparency is 0. Alpha channel transparency is 0. If I just make the transparency a little higher and I change the color, so you can see my jump button is actually covering or consuming the entire screen. Now, why is this? That's simply because when you're going to play Flappy Bird onto your mobile device, you will tap anywhere on the screen. And when you tap anywhere, the bird has to jump, right? So you need to make sure that the button is covering your entire screen area. I'll again revert this back to transparency. And now my transparent button is on my screen. Then we have one more thing over here, game over, which is currently disabled, which is this simply just this retry button. Okay, if we just expand this, all this game over does is it holds the retry button. And within that game over, we have the retry button, which is basically responsible to reload the game. So if you press the retry button, the game will reload. And that's the simple core loop of the game that we've planned. Now, a little bit theory over here. If you want to create a good game, there always needs to be a core loop. What is a core loop? A core loop is that one single activity is inside a game that you will like to do over and over again. Okay, so that is the core loop, and because of this simple structure, we are now entering into that core loop. So the game starts, you start scoring, you start controlling your character, and if you collide with a pipe, you are greeted with a game over screen, and then on the game over screen you can either quit the game or you can retry. And since we retry, we are coming back to the same code loop. So it's more like a circular structure that you have, wherein you start the game, there's game over screen over there, and then you kind of want to retry the game, right? So this is the canvas, this is the UI that is responsible for you to kind of keep on going into that code loop. Okay, now with that in mind, if we can once again play the game, I start the play button, and we'll now start to analyze exactly what functionality there is, and we will try to break down in terms of code what we have done. So the first thing is our player. Okay, the bird itself. When we tap on the screen, the player moves upward. Now in Unity Game Engine, we have something known as components. So we have multiple different components. On the right hand side, we have transform. Transform is basically a holder of all your position, rotation, or scale. We have the sprite renderer, which is responsible for displaying what sprite we are showing. And we saw what a sprite is here in the assets folder, right? We have the sprite over here. So the bird image is basically what is the sprite. So if I uncheck this sprite renderer, my bird will vanish from the screen, but we don't want that to happen. So obviously we have the bird visible. The next component is player script. This is a custom created script. I have written this script. Okay, player script is something that I have written. And within that, we have jump force. We will read the script as well just after this. I just want to kind of set the context. Then we have something known as a rigid body 2D and a circle collider. Circle collider, what a collider does is it kind of tracks if your object is overlapping with another object, right? Collision detection. So something like, my hands are this action is basically my hand is colliding with the other hand, right? So we want to test for collision whether our player is colliding with another pipe, right? And if we want to do that, we need to have some sort of a collision inside our character. A similar collider is also on our pipes, which we'll get to a little later. But now let's come to the player script. If I just open my player script, you can see it is a very small 60 line code. And even from the 60 line, I'll just kind of zoom in a little. One sec. Yeah. So even from the 60 line code, around about line number 5 to 25, this is just a comment. This is just my self promotion of all my websites and all. So from 60, if we were to deduct 25, I'll quickly use a calculator because I'm always bad at math. So this is just a 35 line code. Okay. And what is happening over here within our start button, there are four functions that are keeping track. One is our start, second is jump, third is on trigger enter, and fourth is on collision enter. Now, what is on trigger enter and what is on collision enter? When it comes to collision, there are two fundamental types of collision. One is your regular collision, second is your trigger collision. Now, you may wonder what is a trigger collision. I'll give you a live demonstration of what a trigger collision is. If we just break down our Flappy Bird game, you will come to understand what this collision type is, right? So here we have the bird. If it collides with this pipe, then it's game over. But if it crosses from this section, that is this gap in between, then you save yourself and you score a point. Now, how in the world will my computer or my code understand that there is a collision? You need to have some sort of an indicator for the code to kind of recognize that my object has passed through. And as you can see over here, in my pipe itself, if you can see this clearly, there is one collision. I'll just zoom in as much as I can. So on the pipe sprite, we have this one collider, then we have a second collider in the middle, and then there's a third collider on the bottom pipe. I'll just quickly kind of click on this pipe and try to demonstrate you what are the different types of collisions that we have. So on the left hand side hierarchy over here, you can see we have three objects: pipe up, score, and pipe down. If I click on pipe up, you can see over here we have three components: transform, sprite renderer, box collider. Now just ignore transform and sprite renderer. We've kind of understood what they do. But let's come to the box collider now. If you can see box collider, this is a vanilla box collider wherein we have not touched any default settings. But if I select my score and I observe my collider over here, there is one fundamental difference between my collider of pipe up and my score. And that difference is that of is trigger. Now what is trigger does is it simply tells the player that you can collide with me, but I'll not stop you. Okay. The simple definition of a trigger is you can collide with me, but I will not stop you. So what is happening is when you are colliding with a pipe. So just as a demo, we'll go ahead once again. When you go through this middle part, although there's a collider, but my bird is not stopping. However, the moment I touch my pipe, there is some sort of a resistance and you can't pass through that, right? If you collide over here, you're bound to get stopped by the pipe itself. However, if you're colliding with this part, this area is not stopping you, and that you can use to increment your score. Okay. So in start, what we are doing is we are basically just giving reference of this rigid body. We are whenever we want to manipulate any component, we need to be able to cache that into a variable. Cache in the sense cache. Okay, cache that into a variable. What we have done over here is we have created a variable of type rigid body 2D, and this is straightforward because our bird over here on the right hand side, bird had 5 components. One of them was rigid body 2D. Now, this is how easy it is. In Unity, anything and everything that you see inside your component can directly be typed as a code. And that is also true for your custom scripts that you create. Now, why do we need rigid body 2D over here? Why do we need the variable this to cache this into a variable? It's because when we click onto the screen or we tap onto the screen, we want our bird to jump. Okay. And how do we jump? Whenever we are dealing with physics, we essentially just add a small jump force in the form of a velocity. Now, as you can see, line number 41, we have created this 39 to 42 line code, which is a custom function called jump. And here, all it does is add a new velocity to the bird. So you can see over here, rigid body dot velocity is equal to new vector to 0 comma jump force. Now, why is this 0 comma jump force? The 0 comma jump force is because our vector is divided into two parts. let me just try and explain this to you in very simple terms. Um, you can see over here, I'll switch to 2D mode. This might be a little tricky to make you all understand, but let me try my level best. So on Flappy Bird is a 2D game. There are two types of games. One is 2D games and second is 3D games. There's also an outlier in between called 2.5D, but we'll not touch that. Something for you all to kind of do a little bit of R&D from your end. Now, in Unity, we have these three axes. Uh, right left is x-axis, and up down is y-axis, and front back is z-axis. So right left, this is x-axis. Okay, up down, if you can see on my camera, up down is your y-axis, and this 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 depth, this is your z-axis. Okay, so I hope the axis part is clear, which is now very pivotal to what I'm about to tell you guys right now. If you read inside our code, we have rigid body dot velocity new vector to 0 comma jump force, which means that in my x-axis I'm not adding any force, but in my y-axis I'm adding a jump force. And what is jump force? Jump force is defined as a variable over here on our line number 30. So basically what will happen over here is, as soon as I access my jump function, my bird will be thrown a little bit up, and there will be jump force acting on it. So basically what is going to happen is, on my bird, whenever I tap the screen, that time my bird will bounce a little. Now the tapping part is clear, the functionality is clear. We've created the function which is right over here. But where is this mapped? This the like for we've written the code, that's great. But when it comes to our keyboard or your mouse input, that's pretty much straightforward, right? You press some button and that will happen. Here, what we've done is we have simply just created a function, and we have not specified where it is going to be accessed from. So what happens exactly now is, if you recall, we had already created our jump button, which was this transparent button that was covering our entire screen, right? This is a red thing that I've just changed the transparency of. So what we have done over here is, within our jump button in Unity UI framework, on the right hand side, if you see, you have something known as your on click function, which basically denotes that whenever my object is clicked or when my button is clicked, something should happen. And I don't know how visible this is properly on a Zoom interface, but on the right hand side, we have this reference of our bird player. So as soon as I click on this, you can see the bird gets highlighted in yellow. Okay, I click this, bird gets highlighted in yellow. And what this basically means is that, okay, we have written a function. Now that function needs to be accessed. So as soon as I drag my bird into this as a reference, you will see that within this, there will be multiple options that you can choose. And if you see some sort of a pattern over here, you can see that the each and every option mentioned over here is actually a component on the object this where we are accessing. So if I just go to my bird, you can see over here on the right hand side, there is transform, sprite renderer, player, rigid body 2D, and circle collider 2D. If I come back to my jump button, you will see those functions in that very order. So transform, sprite renderer, player, rigid body 2D, and circle collider. Now, if I hover onto my player, what we want is, from the script is, when that button is pressed, this should get executed, right? So I go back to my Unity. I see, select go to player, and we already have the option of jump ready in place, right? Now, this has happened because this is a public function, which basically means that my function is accessible from anywhere. If this was a private function, something like uh, if we didn't mention the keyword public, and I just save this and I go back to my Unity. Now, after this compiles, there will be an error, and I will, like, when I play this again, there will be some sort of, oh, okay, this is still working because this has a reference of the previous one. But if I drag my bird onto here right now and I go ahead and I go to my player, you'll see that my jump option has vanished from here. And that's just because that function is not public. Let's fix that again. I'll just put the keyword public, go back to my Unity, and compilation has finished. Clear, and you can see the jump option is visible over here. Okay, so it's just something to keep in mind if, say, you are working with UI and you are not able to find the function that you want to execute. Just make sure that the keyword public is mentioned. Otherwise, your options will not get visible. That's one. Now, there are two major functionalities, trigger and collision enter, 2D. Of course, what we've done over here is if we are colliding with our pipe, that's when we initiate game over. And if we are going through or passing through that pipe, you can score. So over here on line number 46, what we've done is we are comparing the game object that we are colliding with. So in Unity, we have something known as the tag system. Tag is simply just a reference or an identifier to an object that you are going to collide with. Okay. So if we go to Unity, I go back to my pipe, and you can see over here, in pipe up, we have a tag of kill. If I go to my score, I have a tag of score. I know the text is very bleakly visible, might be bleakly visible, but I'll try to explain it as much as I can. And if we select pipe down, we have the tag kill. Same pattern is over here. If my game object tag is score, then this function should get executed. If my game object tag is kill, then my game over should be executed. Very simple, very straightforward. And what is score increment, what is game over, that is something that we will explore shortly. But at its core, what is happening is, as soon as my player collides with any object, it also needs to know what it is colliding with, because this is a very simple game. But when you're creating something complex, there can be n number of objects, and you need to make sure that you are if you want to detect a collision with a particular object, then only that functionality needs to get triggered, right? So in that sense, you will then keep on adding multiple if statements, and you will keep on comparing tags. There can be any other thing, like collision enter 2D. When you're colliding with one object, you will kind of maybe have a collision in place of colliding with other car. Say you are driving a car and you collide with another car, and that can be one type of collision. Then say you can, if you're driving a car, maybe you can collide with a dustbin on the road, or maybe you collide with a wall that is completely static, right? So that is why it is very important for you all to keep a tag of all the objects that you are going to collide with. Second part, now let's come to the pipe. Okay, we've discovered what our code for player is. Let's see what is happening on the pipe side. So we've already created this prefab script, and we know that we want to create pipes at random intervals, and once they spawn, we will kind of make them move backward. Now again, this is also a very small script. If you get rid of all the comments, right now it is 48 lines code. So 48 minus 25 is basically just around about 23 lines of code. Here again, we have two public variables. One is the move speed, which is responsible for our object to go back, and second part is kill position X, which means that if our position is beyond a certain position, then we destroy that object. And the same can be seen over here as well. Here at line number 41, I've done something that is more of an edge case, because I'll show you what happens if I remove this line. What this does is basically it stops generating new pipes, or it triggers my game over mode, and it kind of makes sure that the pipes stop moving after that. So say for example, if I remove line number 41, I turn this into comment, and I go back to my Unity, and now when I hit the play button, and assuming I collide with a pipe, now these pipes will keep on moving, right? Although the game has stopped generating new pipes, but whatever is there on the screen is still moving. And that can kind of lead to unnecessary scenarios, that can lead to some collision bugs happening and all, which kind of also adds into my point that even if this is a small game, such minor things can actually go south and make your game, buggy. On line number 42, here is something that we will kind of demonstrate, which is slightly different than what we've done in the player, but a little bit on the similar lines. So we want to move pipe from right to left. Okay, we want to move the pipe from right to left, which is where we access its position and we negate something known as a move speed. What is happening over here is that the pipe is moving every single unit with this move speed. Okay, and we've defined this at 0.05 over here. If you come to your pipes, we have given this a value of 0.1. Uh, Typically, a good way to also do this. Now, this is a very small piece of code that I've written. I have not factored into account, different hardwares and their performance. But whenever you are moving an object, it is always advisable to use a smoothing factor or a time dot delta time, which I have not done over here. So what I basically mean right by doing this is you just multiply a time dot delta time over here. Now the speed of that pipe will be relatively much slower. However, it will be consistent across all the various different configurations. So I think right now the pipe is moving very slow, at a very slow pace. So I'll just increase the move speed. Instead of 0.1, we'll make it 1. And I think this is still very slow. Okay. So you can basically just tweak around with these values. I mean, it's completely your game, right? So you can tweak these values as per your liking. So I've done this at 10. This is fast. This was too fast. But anyway, I mean, you get the point. You can basically tweak around with the game code and make sure that you have values as per your liking. Obviously, this was a last minute change, so I'm just going to keep the code as it is, reverted back to the previous state. You can do this optimization, you can do this change on your side and see how what is a desirable effect for you. Coming back to Unity now, the last thing in this is our game manager, which is very important. We also have UI manager, but this is basically just responsible for updating your score and showing it to the user. And over here, what is happening is inside when a player scores a point, this function gets called and this updates that text. If we go back to Unity in my UI manager, we have all the references to all these objects. So score text has the reference of score. Game panel has the reference of game panel, and game over has a reference of game over panel. What this means is that whenever your game is active, you show the player your game panel, which is already on. And if your game is over, then you turn on the game over panel and turn off the game panel. And that is exactly what is happening over here. So it's kind of self-explanatory in that sense. And update score is called every time your score gets incremented. Now, the last thing in terms of your Flappy Bird game is your game manager. If you can see over here, we have two things. One is your score, and second is your game over. And here's a check mark, which basically means that your game over is of type Boolean, and Boolean is either true or false, right? So very basic, like fundamental code knowledge. And once again, of course, 25 lines of comments, 68 line code. So 68 minus 25, around about 43 lines of code, and your functionality is done. And obviously, we also have like spaces, and also the base code is very small in comparison to that. Now, this entire thing from line number 30 to 43 is basically a singleton pattern. What is a singleton pattern? Singleton pattern allows you to access a class from virtually anywhere. I mean, if you can access game manager from your player class, you can access game manager from your UI, from your player, whatever. I mean, game manager is converted into an instance. It's a um, it's it's a singleton that can be accessed from anywhere. Okay, so this is a singleton pattern. You can use this, and I've used this singleton pattern inside my UI manager as well. So you can see in my UI manager, uh, from line number 30 again to 43, this is a singleton pattern from UI manager. And to see this thing in action, we have to go to our player manager, and you can see game manager.instance.score increment. which this is what it means basically, that game manager, we are not taking any reference. So if we go to Unity, I go to my say canvas or score, or even if we go to UI manager, we are taking reference of score, game panel, game over, whatever, right? However, when it comes to your game manager within our player or within our UI, we are not taking any reference of our game manager. If you are new to Unity, this might be a little fancy for you all, but if you see in the other way around, it actually makes sense, you know. Of course, word of caution on singletons as well. Do not use singletons a lot because it kind of occupies space inside your memory, and you need to make sure that there's no duplication in terms of using singleton. Of course, that's a theory part, but you know, something to ponder upon later. Within our game manager now, we have three major functions. One is your score increment, second is your game over, and third is your reload game. Again, very much self-explanatory. If we see score increment, this takes care of the score. We have defined score over here that is initiated with 0. Obviously, when we start, the score is at 0. And every time score increment is called, which means we pass through from that middle section, we score 1 point. And after this, once my score is done, we need to notify the UI manager to notify the player that their score has incremented. Obviously, if we leave this part out, if we leave out the UI manager update score, then it will not it will not display the score to the user. Although at the backend score is getting incremented, but it will never inform the user that your score has increased. Then we have game over, which we have a Boolean variable, and this Boolean variable is a check to allow everyone to know that the game is now over, something that we've used in our pipes. So for line number 41, as I said, right, if player's game is over, then you don't move the pipes from right to left. And this is the variable that keeps track. And again, the UI manager is then notified that the game is over. And once that is done, then we are showing the player the game over screen. Then we have reload game, which basically just reloads the scene. So if we go back to Unity, go to your assets folder, scenes folder, the name of this scene is sample scene, exactly what it is over here, sample scene. Okay. So we essentially just reload that screen. And that, my friends, is Flappy Bird for you all in Unity in less than an hour. This is something that you can create on your end in a matter of a few hours. If you are completely new to Unity, then it will take you like a few hours to set this up. And with that in mind, I would urge you all to create such smaller projects. Don't go after creating big games at your very first try, because chances are that you are even within this game there are so many nuts and bolts that you need to account for. And if you create bigger games, then it might not suit your purpose, or it might also kind of uh, you know run you into lack of motivation to complete the game. So with that in mind, guys, I hope I did a good job in explaining all of this to you all.